Hi, we are Team 25 for the course Cluster and Cloud Computing. This video talks about the scenario for our project and demonstrate the web application, and then some findings will be discussed. Our scenario focuses on the economic factors that contribute to homelessness, in particular focusing on rental prices, mortgage payments, and family income. And we have gathered data from three main sources: Twitter, Pseudo, and Mastodon. We've collected kinds of tweets mentioning homelessness, rental prices, mortgage payments, and family income across each greater capital city. And do the same to Mastodon data, but instead we have daily kinds of posts. And we also utilize Pseudo for detailed data on the number of homeless people, weekly rents, mortgage payments, and total family income in each area for 1 year. We aim to uncover correlations and trends between those factors and the homelessness. So let's move to the front end, and some interesting findings will be mentioned.
Our application uses React.js, and users can easily access our homepage and chat visualization page. Upon landing on our homepage, you will see a title with our group name and topic. This is followed by the role of each group member. And lastly is a brief discussion of our topic. By navigating to our chat section, you will find a variety of chats to observe the relationships between the data. And we created a function, click button to get data. Let's fetch data from the Twitter and Pseudo APIs. When a button is clicked, the data fetched depends on the type of data selected: income, mortgage, or rental. Once the data is retrieved, we update our state with the new data and review the plots. And we use the same approach for Mastodon button. When button is clicked, it will fetch data from Mastodon APIs. Then we can get homeless, rental, income, mortgage data to create line chat.
Okay, now it's now up to me to present the interesting findings after the simple analysis of data. First, we chose to use stepped bar chart to analyze the Twitter data and Pseudo data for different regions. What we can see is that in regions with more Twitter data, the number of tweets that mention homeless is higher. The same is true for the Pseudo data. The three variables of income, mortgage, and the rental were then chosen to be correlated with homeless for linear analysis. Interestingly, all three variables in the Twitter data showed a positive relationship with homeless, and meaning that the more people discussing income, mortgage, and rental in Twitter, the more discussions about homeless. In the Pseudo data, however, all three variables shows a negative relationship with homeless. This also suggests that the higher the income, mortgage, and rental, the lower the homeless. This was explained by our group. Firstly, we proposed that if a social problem is serious, then the number of people mentioning it on Twitter will become higher. So, for example, if an increase in regional income in the Pseudo data reduces the social problems caused by income, then fewer people will talk about it on Twitter. This also leads to fewer people discussing homeless on Twitter, and therefore the area will have fewer homeless people in the Pseudo data. The data for the Mastodon were then analyzed. Due to the small amount of data on Mastodon and the fact that detailed IP addresses are not available on Mastodon, we chose to use time curves for our analysis. As can be seen from this graph, the peaks for the three variables, income, mortgage, and rental match the peaks of homeless for homeless. This confirms our conclusion from the Twitter data that the more people talk about the income, mortgage, and rental, the more people talk about homeless.